What about something that says y equals 2 sine theta? What is my graph? Let's have Mr. Resendez help me with this one. Mr. Resendez, first of all, when you see a 2 sitting there, what would you expect to have happen? What's the phrase we used? Stretch by a factor 2. In other words, my y values go up by 2. Great. So if I have a wave or a sine function starts at 0. So what's 0 times 2? 0. Aha. I'm going to put pi here and 2 pi over here. What happens at pi? Pi, we're at 0 again, aren't we? What's 2 times pi? 2 times 0?
0.
0. And then at 2 pi, we're at 0. So what do we get for that?
2 pi, we're at 0.
At 2 pi, we're at 0. So 0 would be 0 times 2 is?
4.
0 times 2 is? 0. That's when you know you asked a bad question. You get it right the first 2 times, you get it wrong the third time. All right. Now, at pi over 2, where is sine normally?
That's pi over 2.
At pi over 2, if I'm going to draw my graph, where would I normally be?
1.
1. But since I'm multiplying 1 times 2, the sine of pi over 2 is still going to be 1. What's 1 times 2? 2. So this thing's going to be up here at 2 instead. And so 0 is going to be 0, but when I get negative 1, what am I really going to get now? Negative 2. So I'm going to be down at negative 2. So the graph now becomes like this, where the amplitude is 2. Now, a little note on amplitude. People struggle with this. Amplitude is the distance from the top to the midpoint, or the bottom to the midpoint. It is not from the top to the bottom. People struggle with this. Not so long ago, I used to live at a place called Newport Beach, California. We used to have waves come in. And they would say the waves coming in would be how high? They say 4 feet. And so these people from Iowa or whatever, 4-foot tall wave, that's like here, right? They're talking about amplitude. 4-foot tall wave is what? Your head's down here. There's an 8-foot tall water wave in front of your face. Yeah. When they had 12-foot swells, it's a 2-story building coming at you. When your head's like this above the water. Yeah. Okay. So amplitude only refers to half the distance between the top and the bottom. That's something you need to write a note on. Make sure that's crystal clear in your head, because that is something that I'll get you on later.
Half the distance from the top to the bottom.
From the top to the bottom, it's half the distance. So here, from 2 to negative 2 would be how far?
4.
4. And so half that would be 2. Amplitude refers to from the middle to the top, or from the middle to the bottom, which is just 2. So it's half the distance from top to bottom. And so when we say stretch by a factor of 2, Mr. Resendez, in this chapter we're going to say it has an amplitude of 2. Can a wave have a negative amplitude? The answer is no. A negative out in front does what to me? What does a negative out in front do? Reflects, right? It flips it over the axis. So a negative 2 sine theta, if I go y equals negative 2 sine theta, I would end up with this instead, right? Where this is negative 2 and this is positive 2. I would still say my amplitude is 2, though. Okay? The negative just tells me I start by going down instead of up. Okay? So far with me. Make sense? Good, everybody? All right, so that's the first of the 4 different things we have to learn how to play with. The second one is a little trickier. It has to do with how often this repeats. Because one of the bummers of the current form that we have for this equation is, now I've taught you, hey, I got a wave. It's now 8 feet tall, right? Do the waves always come in 2 pi apart from each other? That would be really convenient, wouldn't it? But they don't. The period changes. That's unfortunate. What if I were to, in my equation, how would I change my period? The answer is, I would look inside my equation, I would go, y equals sine, and in parentheses, I'm going to put a 2 there. Does that make sense? And then I'm going to put my little, you want to put an x or a theta. Who wants it? Resendez, x or theta? X, all right. Here, 3 people say theta, so you went with x. Good man. Did your convictions. All right, so I've got y. So how does this change my gap between? I just said change the gap between. How does it change gap between? Well, imagine for a moment I put pi in here, right? Miss D's, if I put pi in here, what does this effectively become? 2 pi, which means I'm already done with my cycle, right? So this would have a period of pi. So this wave, this one I'm talking about right here, would whoop, whoop, whoop. But instead of being done in 2 pi, it would have to be done by pi. Because when I put pi in here, it acts like 2 pi. Make sense?
So, no.
Pausing again. All right. I heard a no in the front and a no over here. Let me get the no in the front first. I think I heard it first. What happens when I put pi in here?
Becomes a full
2 pi, and 2 pi sine times 2 pi is back to 0. It's the very end of the graph. So when I put pi in this graph, I'm already done with my whole thing. If I put pi over 2 in here, what's pi over 2 times 2? It's pi. And sine of pi is also 0. It's the one in the middle.
I still don't. How does that change your graph?
Well, normally I end where? Now if I put a pi in, I'm ending. So now when I put a pi in, I'm already done with my graph, right?
But you are. But when you put a pi in, you're 2 pi.
Right.
Like the graph to the left. You know.
So if I put a pi in, here's my XY chart, right? I'm putting XY. If I put a pi in,
Yeah.
I get out 0, right? If I put in a pi over 2, I get 0. If I put in a 0, I get 0. So these 3 points are here, here, and here. When I have my original graph, y equals sine x. If I put in a 0, what do I get?
0.
I get 0. If I put in a pi over 2, the sine of pi over 2 is just 1, right? So I'm up at 1. If I put in a pi, I'm at 0. So that would be this point, and that point, right?
Mm-hmm.
Whereas if I put it in for this graph, I got this point, and that point. I'm already done with my graph. I've already gone through a full period, full cycle.
So the full cycle has to hit the same point 3 times?
That is a terrible thing you just said, so I have to figure out what I'm doing wrong here.
Because I'm confused, like, why you wouldn't just...
All right, we're going to do something boring. Let's do something boring. Y equals sine. Let's do cosine just for the fun of it. Cosine 2x. With me?
Yeah.
I'm just going to graph it boring style. So let's plug in some points. I got 0. Let's do pi over 4, pi over 2, 3 pi over 4, and let's do pi, and then let's do 5 pi over 4. Okay, so I want you to put this in your calculator, get your calculator out, get radians. Let's go. Let's get some points. Let's graph this old school style. 1. Now let's do a normal graph. So pi over 2, pi, 3 pi over 2, and 2 pi, right? That's our normal graph paper, right?
Yep.
So at 0, we're at 1. At pi over 4, well, that's not even this far. It's halfway there, right? We're at what? 0. At pi over 2, we're at -1. At 3 pi over 4, which would be halfway between these two, we're at 0. At pi, we're at 1. At 5 pi over 2, where are we at? Or 5 pi over 4, where are we at? 0. So what's the graph look like?
Is that a full cycle?
Isn't that a full cycle? We started at the top, we ended at the top, didn't we? So it's not about 3 dots. It's about when you go through a full cycle, right? And it does a full cycle by what time?
Pi.
In pi instead of 2 pi. So this number right here changes how long it takes to go through a cycle. Instead of it being 2 pi, I can make it any number I want by messing with this number right here. Okay?
So, in the regular graph, there's no number. So it's just like...
So normally, we have y equals cosine of x, which would be normally 2 pi. But remember, there's a visible 1 here, isn't there? Always. So it's the normal as 1. When I make it a 2, suddenly I have half as long a period.
So, like, the bigger the number, the faster you go through.
Faster you go through a cycle. It's actually called angular velocity, but we don't want to talk about that at all. See your physics teacher after you've taken 2 years of physics. But we do want to talk about how do we predict what the period is. We just said when it's 2, it means my period's cut in half. So what am I doing with that 2? I'm dividing it, aren't I? So here's the formula you're going to need. Period equals 2 pi over k.
So,
Period, by the way, is a tau. A tau. It's supposed to look like a weird-looking T. It's the Greek T, which is also used for torque in physics class.
But is that a K?
That's a K on the bottom. Okay? So the formula we've thus far discovered is y equals a sine, I'm just using sine, it can be sine or cosine, k pi, no, sorry, k, we said x is what we're going to use, so we'll use x, no we won't, x, right? This tells me my amplitude, this tells me, this is weird, I use it in the formula, period equals 2 pi over k to determine my period. And k is that number that's in front of the x. That's it. It's called your angular velocity, but you don't need to know that because this is a trig class, and we just don't know things like that. We don't care. It's math. Just give me the math. Now, beautiful so far? So if I'm going to graph something, let me graph something for you. Let me graph something easy. Let's do y equals, I'm going to pick a different color, 3, sine or cosine? Resendez.
Sine.
Sine. I'm going to use 4. No, I'm not. I'm going to use, yeah, I'm going to use 4. Never mind. I'm going to use 4. And then I'm going to use a normal x that we've always been dealing with.
Could that be theta too, you said earlier?
Could be a theta. Matter of fact, I'm going to use theta mostly. We're going to use a t later on in the chapter for reasons we're going to talk about time. Okay? But right now, it's an x because that's what Resendez wants. And we were going to go with it. Okay, so I'm going to go fast here. So this 3 refers to my amplitude. Right? My amplitude is going to be 3. My period is going to be 2 pi over 4. And I'm going to graph what function? What's my parent graph? Sine. So this should have been at first. Y equals sine x. So here I go. I'm going to graph this as fast as I possibly can because I'm running out of time for a reason I can't even explain to you. Oh, colors getting bigger. Boom. Close. Here we go. So we're going to do changing, shifting, all that stuff. So what does sine y equals sine x usually look like?
Starts at 1.
Starts at 0, right?
Yep.
And then let's make this pi over 2, pi, 3 pi over 2, and 2 pi, right? So normally it would go up to 1. Let's make this 1. Let's make this -1. It would go up to 1, down to here, down to negative. Oh, that's not 1. Missed 1. Normally, normal. 4 seconds. 5, this is what the graph looks like.